Hello and welcome to the third installment in our series of live sessions meant to educate kids primarily from classes 8 to 12 about artificial intelligence. After the previous session, a lot of you guys have requested a session on foundations of AI. Hence, here we are. This talk will be an informative session on artificial intelligence. The purpose of this discussion is to give you a certain amount of awareness about AI as a technology. The reason you should be aware of this is because you guys will soon be, if not already, the primary customers to a lot of companies that sell products and services built using AI. And as customers, you should be aware of what you are buying. So this will be a purely conceptual discussion with some facts and information. So sit back and stay attentive. And by the end of the discussion, you will have enough understanding of artificial intelligence for you to be able to sound smart among your friends and family by having a conversation about it. All right. Speaking of attention and keeping up with the tradition of our live sessions, I have a question for you. And I want you guys to answer the question in the comment section. So what is the name of the weapon that Thor uses to fight Thanos in the Avengers? Take a couple of seconds to answer that question. And let's see how attentive my audience is. All right, so no answers yet, but let's just move on. So the answer is Stormbreaker. Stormbreaker was the answer. Anyway, so the overall agenda that we have for this session is we'll cover three main ideas: the origin of AI, a little bit of history of it, and the early applications that we did with AI, the progress that AI has made as a technology, and the few specific milestones it had, and one of few of the very key application areas that we currently use in most business cases, and also the state of the art technology of AI that is the most advanced thing that we've been able to achieve using this AI technology. So this is the agenda that we will cover in no specific order. We'll go through all of these ideas one by one. So what is artificial intelligence? So in the previous session, we addressed this term in slight detail, but this time I want you guys to come up with an answer with about your understanding of artificial intelligence. What does this word mean to you? You can actually type in your answers in the comment section and maybe I'll address your understanding. Okay, finally, one comment from Harika. Doing things in a smart way is artificial intelligence, okay? Anyone else wants to take a shot? Intelligence shown by man-made machines, okay? Let's keep the session interactive. I want more answers, guys. Hmm. All right, I think we shall move on. So the reason I bring this question up is because a lot of people have very inflated ideas about what is artificial intelligence. So something like a very advanced robot like Jarvis or Ultron. But there is something called as the dichotomy between hype and reality. So whenever there's a new technology like AI or any other innovative technology that grabs a lot of attention from people, people quickly start having very high inflated unrealistic expectations from that technology. It was the same with the internet. So when the internet first came, people started getting on it, and eventually people started to solve everything that there is using internet, right? And currently even machine learning had to go through that phase, and some might say it's still going through that phase, that people are solving every problem that can be possibly solved with machine learning, even though you don't require it to be solved by machine learning. So it's more like the technology needs a product rather than the product needing the technology. So once people start getting onboarded with this new technology, people have huge expectations from it. Eventually, the expectations die out because not a lot of things work out where they want to use the technology, and eventually it gets into a place where the people see very little promise about the technology. But eventually, the technology matures, and the people also find ways to, figure out ways to use the technology in a very realistic way and build products that increase the overall productivity of humans. So this is something that even AI is kind of going through. So depending on who you ask, different people might have different answers on where in this graph the current situation is with AI. So this is what a lot of people have in mind: a very inflated, high level, let's say, image of artificial intelligence. So eventually, during this discussion, we'll see what is the current reality of AI. Now, the definition of AI has never been one. So the definition of AI has always been evolving over the years. So anything that felt smart for a machine to do was called as artificial intelligence. And this definition kept evolving. And right now, we have an idea where if an AI is able to do something that takes some amount of intelligence or understanding of environment, and the AI is able to respond to the environment, then we call it, if the machine is able to respond to the environment, we call it as artificial intelligence. Even something as simple as identifying a dog. Now, if you guys can look at this picture, you see pictures of dogs and muffins. Can you tell the difference between the dogs and muffins? Can you identify which of these little boxes have dogs in it and which of the boxes has muffins in it? Now, a lot of people, when asked this question, will probably get it right. And if I ask you, how easy was the task? Was it easy, medium, or difficult to identify the dogs from the muffins? And for a lot of people, this will be very likely too easy, but machines struggle to do this. So thinking of a machine like Chitti or Ultron is way, way beyond the current reality. So the current situation of machine is that it finds it very hard to distinguish between these pictures. So muffins and dogs, it often confuses between the two. But also we do have machines that outsmart humans in very specific tasks, like in the game of chess. So the first ever time a machine was able to beat uh, the best player in the world in the game of chess was in 1997 when IBM's machine called Deep Blue could beat the player Gary Kasparov in a chess game. And this was a big milestone in the research of AI, and it got a lot of attention. The technology got a lot of attention, and it quickly people started building up expectations on it. And almost 2 decades later, there's another game that machine, the AlphaGo, the machine that was built using the deep learning technology. And this was built by a team of researchers at AlphaGo, which was later acquired by Google. So this machine could beat the best AlphaGo player among humans in a very record time. And this was a significantly bigger achievement than the chess because Go is a much more complicated game than chess in terms of the number of possible moves at every point during the game. So these were a couple of very significant milestones in AI research, but these are very specific, and these very specific tasks only the machines have been able to beat humans. And we are still far away from getting to machines that are not just specific to tasks, but also general purpose AI. So the closest thing that we have to general AI is a Google Assistant or Alexa or Siri. So there's a lot of heavy machine learning that goes into building a voice bot like a Google Assistant because it has to respond to different variations of the same question, and things can get very complicated with the questions and the answers and the responses, and depending on the environment it has to identify the voice of a person, and it gets quite complicated to do that. And in a few cases, the Google Assistant has also been able to pass the Turing test. Turing test is something that we use to test a machine if it is able to pretend to be human successfully. So if a Turing test is something like this. So we have three agents. One agent asks questions. The other is a player, a human player, and the third thing is the machine. So the questionnaire asks questions to these two people, the two agents, the human and the machine, and both of them answer. And if the questionnaire cannot decide which one answered which answer came from which of the two, then that machine is said to have passed the Turing test. It basically means that the machine was successful in pretending to be human. So this is the closest state-of-the-art thing that we have regarding artificial intelligence that can behave very much like humans. So all of this was possible due to something called as machine learning. So even before machine learning, we still did have machines that could behave intelligently. There are other things that we can use to have that programmed into a machine to behave intelligently. But machine learning was something very significant. It changed things very drastically. So all of this Google Assistant and AlphaGo was possible because of machine learning and deep learning. So what is machine learning? So soon after we started to build computers, we realized that we cannot build intelligent machines using traditional rule-based programming. So without machine learning, the programming was very complex. If you had to build a robot that can play chess without machine learning, the lines of code will be very long. It's a very big task because you have to write rules for everything. When you have this certain situation, you have to act this way. So everything has to be hard coded. So when we tried to build computers to behave intelligently like that, we realized that traditional rule-based programming doesn't work. So for machines to perform like humans, they have to be taught like humans. The humans learn through experience, and for machines, experience is nothing but data. Machine learning in general, to give you a definition, is nothing but a study of algorithms that can learn from data. So the first ever instance of the use of machine learning in building a computer system that could behave intelligently was somewhere in the 1950s, and it was late 1950s, and it was made by a guy named computer scientist Arthur Samuel Lee. So this was one of the first ever AI systems created using machine learning. This system that he had created could play checkers, which is a game, with a human, and it got good enough to beat an amateur player at the game. It was still wasn't good enough to beat the best human players, but it was still maturing at the time, and eventually, at some point, it could beat a regular player, checkers player. Now, this was the first instance of machine learning being used to develop systems. Now, after that, there were a lot of innovations and a lot of things happen. And overall, machine learning has enabled AI in very different areas of applications that we currently use in our everyday lives without even noticing. So the relationship between machine learning and AI is something like this. So machine AI, artificial intelligence is a broader field, and machine learning is a subset of that field. So AI is the ability for machines to learn from data or machines to behave intelligently and pretend to be human. And machine learning is one way to enable AI. So the point of this is that even before machine learning, we had things that we could do to have machines behave intelligently. So something like developing a bot in a game. Uh, what game do you think this picture is from? And shoot your answers in the comment section. All right. So this is PUBG, and if you guys have ever played PUBG, you have the actual players, and you also have some bots in it. So these bots do behave like humans, like an actual player trying to shoot you down. But these are not really artificial intelligence. They are programmed in very different ways. They don't use AI. Not currently, though. And these are programmed with different ways like Monte Carlo, search tree, or finite state machines, or something like that, which do not use machine learning, but still give you a sense of intelligence of the machine. So, let me take you through an example of uh, a system which is not machine learning, but still kind of a pretentious AI. So a finite state machine is something that we can use to create a game bot. So we have, so depending on what the bot is currently doing, we can change the behavior of the bot, and it keeps going on in a cycle. Let's say we start somewhere, a bot is wandering. So if a bot sees a player inside, it gets into a situation where it tries to attack. Now, when the if the bot's in a position where the player is attacking, the bot tries to evade from the place. And if the bot is in a place where it needs more health, it goes and finds health. And if the bot has enough health points, it starts wandering again. And if the bot, again, while it wanders, it sees another player, it gets into attack mode. And if the player runs away, instead of the bot running away, it again starts wandering. So this is something you can program into a machine, and the bot can pretty much behave like an actual player. Now, this particular example is a fairly very simplistic way. A much more complicated game like PUBG or any other Call of Duty. In that case, you would have a much more complicated graph, which is something like this, but with a lot many nodes. So we'll have a lot many states in the state machine. So we have finite states, so a limited number of states that a bot can be in, and for different situation, the bot starts changing its state. So this is what a finite state machine means. And these are examples of artificial intelligence that are not machine learning. Now, getting back to artificial intelligence that are machine learning. So once we started using machine learning, there were plenty of opportunities to leverage that technology. So these are some very specific ideas and application areas of machine learning that we've been able to do so far. So let me just take you through what is there in this slide. So machine learning is broadly categorized into three things: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is nothing but you give machine data and you tell the machine what the data means, and the machine learns from it. For example, you can tell the machine that you can give the machine a picture of a dog. You can tell the machine that it's a dog, and when you see a new dog in the future, you have to identify that it's a dog. So you give the machine some 100 pictures of dogs and tell the machine that all of these pictures belong to a dog, and the machine learns from it. This is called a supervised learning. Unsupervised learning is a situation where you do not have where you do not supervise the machine. So in the first case, you told the machine that it is a dog. In unsupervised learning, you don't tell the machine anything. You just give the machine some data, and you just say, learn something from it. Detect patterns, detect this, detect that, cluster data, or put similar things together, all of that. So that comes under unsupervised learning. And reinforcement learning is something that is used primarily in robots or even self-driving cars, and even robots in games. So reinforcement learning is nothing but the bot trying to learn from its own mistakes. So you can tell the bot that this is what you have to achieve in the end. I don't know how you're going to do it, but you have to figure it out. So bot tree keeps trying multiple attempts. It keeps making multiple attempts at trying to get there, and eventually it gets there. So this is called reinforcement learning, the process of going from here to getting there. And these are the broad, let's say, categories of machine learning. And within them, let's take supervised learning as an example. We have classification and regression. So classification, as we discussed earlier, you can give the machine pictures of dogs and cats. You can tell the machine this is a cat, this is a dog, and the machine learns from it. And the machine, when it sees a new animal, which could either be a dog or cat, it can make a prediction. It can make a guess, an informed guess that it could either be a dog or a cat. So this is called as classification, and there are many applications for classification. You can use classification to detect frauds in maybe ATM machines, or detect frauds in banks, detect frauds in credit card defaulters. So you can also detect frauds in cybersecurity. So these are classification applications, even image classification, the dogs and cats that we discussed. Customer retention, you can use machine learning to identify customers who are loyal to the company, and the customers who seem to be on a brink of being lost to the company. So maybe you can target those customers specifically for any certain things. So you can use it for customer retention. You can use it for diagnostics. So machine diagnostics in airplanes or in industries, you can use machine learning to detect if there's any fault in the machine. So the machine can classify between a normal machine and when a machine starts behaving faultily. Similarly, we have regression. We can use it for forecasting, making predictions. So for a given, let's give you a simple example. If you have data of attendance and marks, you can use regression to predict a student's marks based on his attendance, his or her attendance. So if a certain student is attending classes diligently and regularly, he's very likely to get better marks. Not always true, but in most cases, it is true. So we can use machine learning that way. So it's a simple example. There are also very real-time, complicated, and serious applications of regression and all of that. And similarly, unsupervised learning, as we discussed, we have two things: dimensionality reduction, which we won't discuss right now. It needs some background about what data means and what dimensions are. So we can discuss what is clustering. Clustering is nothing but identifying clusters. So if you have, let's say you are in a school and you give 10 questions to every student in the school, maybe 100 questions to every student in the school, and each of the student answers those questions. And using unsupervised learning, using clustering, you can group students who have answered in a similar way. You can train a machine learning algorithm that can identify students which belong to a certain group. So you can group students based on their characteristics, which you would understand by the questions, the way they answer the questions. And also reinforcement learning, as we earlier discussed, we primarily used in uh, game development or gaming, or even space applications use reinforcement learning to some extent, and even self-driving cars and so on and so forth. So these are some very important broad applications and categories of applications that machine learning has to offer. But so far, the greatest invention that humanity could achieve using AI is Snapchat filters and Instagram AI filters. So there's some very serious machine learning and deep learning that goes into making these stickers. It takes heavy amount of mathematics and heavy understanding of artificial intelligence and using state-of-the-art algorithms to actually get to your camera, identifying where your face is and putting a sticker on your face. And even more advanced stickers have things like if you smile, your mouth gets broadened. So all of these require very serious amount of artificial intelligence going in them and developing them. Now, keeping that aside, there are some other serious applications of artificial intelligence, as we discussed earlier. Uh, Self-driving cars. So this particular car is from the company called Waymo, which is owned by Google, and this car has been able to pretty much do almost everything that a human can. But due to government regulation and due to safety issues, it's still not in widespread widespread. I mean, it's not used everywhere, but we do have specific areas in US that use this car in day-to-day life. So even this takes a lot of, it has a lot of serious AI going into it. And another cool application, very state-of-the-art kind of application like the self-driving car, which is the epitome of what we currently have. And the same thing goes with facial recognition. So recently, you might have heard that George Floyd, who was murdered by a policeman. So during all those protests, people were protesting, and the government tried to use AI, facial recognition, Amazon's facial recognition specifically, to identify protesters and maybe charge them later. Even though the protesters were peaceful, government could actually do this. Hence, AI so far has come to a point where we have some very serious applications that can challenge even humans. But a lot of these applications are in very specific areas. We don't have general purpose AI yet. It's still far-fetched. It's a far-fetched idea. And so far, this is what we've been able to achieve. And apart from that, both of these, so this is something, this was self-driving cars involve almost three of the techniques. It requires some supervised learning, some unsupervised learning, and some reinforcement learning. And facial recognition specifically requires supervised learning. And similarly, we have unsupervised application like recommendation systems. So when you log into your Amazon, the way Amazon suggests you products is based on machine learning algorithms that run behind the scene that identify your behavior, your past experience, and your past products, and suggest even depending on the region that you are in, or depending on the age, depending on the gender, it suggests products that you are most likely to buy. And these are some serious applications that we have so far about with artificial intelligence. And same with Netflix. So even Netflix, similar to Amazon, based on the characteristics of the user or the region, the popularity of a certain thing in that region, it suggests you movies and series that you are most likely to watch, and most likely that you'll not close the Netflix window, and most likely to stay in the stay on the site. So the longer you stay, the better it is for the company. So for you to stay there, the company has to provide you with suggestions that are relevant to you. And the way it figures out what is relevant to you is via machine learning. And specifically, we use recommendation systems for these kind of applications. Now we've discussed, so these were some very broad ideas. We've discussed the origin of machine learning. We've discussed the origin of AI, what it means, what AI actually means, the current reality of AI, some state-of-the-art applications of AI, some silly applications of AI, and so far this is what we've been able to achieve through AI. Now I left a lot of things that I hope that you would guys ask during the comment section, whether it's regarding the career or regarding how do you learn AI, what do you need to learn to start doing artificial intelligence or machine learning. So I'll keep this open for some time and you guys can shoot your questions and I'll address them. What business opportunities in AI? So question by Dhanashri Chakrabarti. Yeah, so business opportunities, as we've discussed, so all of these are business opportunities. So as I've said earlier, classification is one good example where you can use it in an actual industry. So if you have machines running in your industry, you can plug in sensors in there. You can train the machine if the sensor is train the machine using the sensor data that when the machine behaves well and it is not going through any trouble, this is what the sensor data looks like. And when the machine goes through some trouble, this is what the sensor data looks like. So the sensors detect some change, it translates into some data, and you can train use a machine learning algorithm using this data, and the machine learning algorithm can classify at any given point if the machine is behaving right or it is behaving faultily. So that is one quick business application that I can give you. And there are a lot more. Like in this slide, you can see these multiple things listed down, and you can later actually explore each one of them and how it is used and see what you find interesting. And maybe you can start learning machine learning by picking up one of these problems. Okay, more questions. Pankaj Jain, how to start with learning AI or ML? So, by the way, a quick question for you guys. Can you suggest, can you reply with what class are you currently in? Just to get an idea of the audience that I'm talking to. And meanwhile, so Pankaj, how to start with learning AI or ML? So so all of these have basis in mathematics. So linear algebra and calculus are the two key things that we use, and AI is generally built upon that. So to actually get started with doing AI, start picking up Python to some extent. You don't have to be a super hardcore programmer in Python to get started with AI. You can just learn some simple, very basic things like data structures and how to use user-defined functions or loops or if-else statements, all of these basic things, get those basics right. And once you get those basics in Python right, pick up a problem. Maybe you can go to kaggle.com, Kaggle.com, and you can pick up a problem there. You can see what other people are doing. You can see how other people are coding. You can take some inspiration. You can also start researching on basic algorithms like linear regression or logistic regression or decision trees to get an idea of what machine learning is and how training and testing and some validation and all of these jargon, how they play out. For that, you need to have some amount of understanding of these basic algorithms before you start building complicated AI deep learning networks. So you can directly jump into that, but it also helps to have some amount of understanding of the basics. So you can start with a little bit of Python, understand what machine learning is. You can go through a bunch of YouTube videos for that. Just Google what is machine learning, and then pick up any algorithm, let's say linear regression. Just pick up that linear regression algorithm, see how it works. Uh, Find out a few case studies on the internet. The best source is Kaggle. So find out a few, on Kaggle, you'll find submissions of people. So go through those submissions, see how it is done, implement it yourself, and eventually start getting better at it. And later you can actually, if you find it interesting and you find it fun, you can sign up for a course online, or maybe you can do it on your own using just YouTube. So either way that you can, this way you can get into learning AI and ML. So there's another question: how easy it is for how easy it is to for an ETL tester to move into AI ML? So as I said, the background doesn't matter very much as long as you're curious about the technology and you're open to learn a little bit of mathematics, a little bit of Python, not a lot, just to get started. You can start learning a little bit of it, and later eventually you'll actually start appreciating it. You'll start missing mathematics. So it is not very easy to get into it, but it is worth the effort. And if you're curious about it, you will definitely like it. I have learned machine learning course foundations course in Great Learning Academy. Is it enough, or should I know anything? Question by Isai. So good question. If currently you have some understanding of machine learning as you've gone through the GLA course, so you can actually, because now that you have a little bit of understanding, as I said earlier, you can pick up a problem and start working on it. And if you are unable to solve that problem, go back to Google, just search what you need to solve that problem and learn, pick it up and try solving the same. So this way you can start continue learning, and without getting roadblocks that you have to learn this much to start doing this. So just start doing this, and if you hit a roadblock, go back to a little bit of learning, learn the thing that you need to solve that, and yeah, that way you can progress in this field without having to break your head too much about what to learn, how much to learn, and when to learn, how fast should you learn, and all of that. Cool. Another question. How does reinforcement learning help you build game or in general in any gaming? So the way reinforcement learning happens is that you have two things. You have a reward and you have a punishment. So you give a machine a certain task. Let's say you want a machine. So if you ever played the game in Google Chrome and you don't have internet, the dinosaur that jumps over the trees. So if you want to train a machine to do that, you can give the machine a reward whenever the machine jumps over a tree, and you can punish the machine whenever it hits a tree. So eventually, and the machine should be biased to get more and more rewards. So you program a machine in such a way that it is greedy for rewards, and as it gets more and more rewards, it eventually gets better at what it is doing. So whenever it hits a tree, it is penalized. So the machine feels bad, and I'm a little dumbing it down a little bit because this needs a little bit of background. But for now, you can have an understanding like this. So whenever a machine does something good, you reward it, and machine understands that what it has done is a good thing, so it tries to repeat it. So you reinforce the machine by doing good things by rewarding it continuously. And whenever the machine does something wrong, you punish it. So the machine never does that. So this is how basically a reinforcement learning works. So another question. Balasubramaniam, uh, business opportunity for AI in India is not that great. All right, more of an opinion. But with the current situation that's happening, it is AI does have a lot of promise in India. So a lot of popular companies, even logistics companies, like there's this company called Delivery, which uses AI to deliver packages far more efficiently than without using AI. So they use a lot of analytics and machine learning to do logistics. So in this way, a lot of businesses are actually using AI in very realistic way, and there is a lot of promise. So yeah, there is good opportunity in India also. Okay, and Abhay Unikrishnan asked which language is better and fast. So AI or machine learning, we've been having a lot of languages over the years to build machine learning or artificial intelligence systems. So one of the earliest languages was something called as Lisp. So Lisp was a high-level programming language, and it was pretty much used to build artificial intelligence systems that uh, you know that are way not very advanced, but still we started with very basic programming languages like Lisp, and eventually people started using C++ and Java and MATLAB to do AI. But currently, the best or the most popular way, maybe not the best, but the most popular way that we use, but that we do AI, or I mean, that we develop AI is using Python. So Python is fairly easy to learn. It is very intuitive. It is and there are a good number of libraries and matured libraries that you can use instead of going through instead of you coding every little detail about the algorithm. You have pre-trained algorithms. You have predefined functions and algorithms that you can directly use as black boxes. So you can just import, use them, and solve your problem without having to learn everything. So Python is better, and it is slightly slower than other languages, but for development purposes, it is right now the most popular one that is being used. Should we learn to write? Okay, Ashwini Kole asks, should we learn to write neural networks when learning machine learning simultaneously? Would this be helpful in building a project in machine learning? So neural networks are not separate from machine learning. It's just that there is traditional machine learning, or some people call it classical machine learning, which uses algorithms like decision trees or support vector machines or linear regression. And there are a little bit of different contemporary machine learning algorithms that are based on neural networks. So you don't have to think. It's not a either or question. You can do both. You can start understanding the concepts of machine learning and pick up one algorithm after the other. So you can maybe start with linear and logistic regression. Once you get an idea, you will understand what machine learning is and how training happens, some of the key concepts, some of the key words and terminologies. Once you get comfortable with that, maybe you can directly jump into neural networks and understand how to and eventually understand how deep neural networks works, and maybe even advanced things like natural language processing and computer vision or facial recognition, and you can do all of that. So you don't essentially have to learn all the algorithms that machine learning has, but a few basic algorithms does help to give you that basic understanding first, and then you can build on it. And is simulation related to AI? Dhanashri Chakravarti. So you can have simulations that depend on AI, or you can have simulations that are independent, or I mean, where you do not have to code AI. So it is related in a way that you can use AI in creating simulations, but it is not a necessity. Okay, what is simulation? Simulation is anything like let's say if you want to understand what would happen if you throw a nuclear bomb at the moon. So you can't actually do that, but if you wanted to see what would happen, you would run a simulation. So you can code in all the laws of physics into the program. So in the program, the bomb goes and hits the moon, and you can see what would happen if you actually hit the moon without having to actually hit the moon. So that's what basically simulation means. Just simulating a real-time environment. Okay, Mohammed Imtiaz Ahmed asks, what is better, Azure ML, IBM Cloud Watson, Google Collabs for accurate forecast prediction using models? So, for the others to give you guys an idea, so Azure ML, IBM Cloud Watson, and Google Collabs, all of these are platforms that we can use to build machine learning solutions or products. So Azure ML is more of a very high level product where you can actually drag and drop algorithms. You can also have pre-trained algorithms. You can use pre-implemented algorithms in the code, and it works pretty well. So which is better? It depends on a lot of things. So there's no one thing that one platform that completely stands out, but three of them are very different. So depending on the application, depending on the skill level of the user, you might have to use different tools like these. And Google Colab specifically is just a platform where you can actually sit and write all of your codes. It's a little lower level than Azure ML. Azure ML is more abstract than Google Colab. Okay, Rahil Sheikh asks, hi sir, I come to know that for AI-related jobs, one should have experience in IT domain. Is it right? So not necessarily. We have professors in our institute who did not previously had a background in computer science specifically. They were from other domains, maybe engineering, mechanical, or maybe other aeronautical or electronics domains, but still they could get into machine learning, and you do not necessarily have to have an IT job to get into learning AI or even getting a job in AI. You can just start picking up the skills, understand the whole concept around what it is, how it is used, and you're good to go. All right. Let's see if we'll have more questions. All right, I think that is the end of the questionnaire. Let's just wait for a couple of seconds. If any of you guys have any other questions, feel free to share. All right, I believe there's no more questions. So thank you guys for joining. Hope to see you guys again soon. Oh, all right. How much does the statistics plays role? How much statistics play roles in of decision making? It's a very broad question. So depending on the application, you use analytics and statistics to, yeah, I mean, to give you a, a short answer, it plays a very huge role. So in most business cases, we don't actually use all complicated artificial intelligence, machine learning. We generally use some basic statistics and some basic statistical concepts to get around into making the right decisions for the business. So statistics do play a very important role. Okay, Isai asked which one is best for building applications either using Python or build ML or use any other platform like AWS. So Python is a language, AWS is a tool, and Google, I believe you mean Google Colab, so even that is a tool. So you can use Python to build machine learning solutions. At the same time, you can use other tools which are already built using or either Python or C++ or based on other languages, which are high-level tools that do not need any programming, and you can use those. So for practical applications, maybe you can use high-level tools like that. But if you want to learn machine learning, you have to get around with Python or any other language that you're comfortable with to learn machine learning. So most popularly, we suggest Python. Okay, there's the last question. Is there any difference between strong AI and weak AI? So I'm not sure what the exact jargon means. If by strong AI, if you mean general purpose AI, there is a difference between a general purpose AI and a specific task specific AI. Task specific AIs are designed to solve very specific problems, like we've earlier seen. Playing chess or playing Go games, these are very task specific AIs, and general purpose AIs would be, I believe, the jargon is strong for that. All right, so let me end the session here. Thank you guys for watching, and really appreciate your questions. And feel free to head over to the GL Academy page to explore even more sessions from us. And thank you guys.